Hello everyone. In this session we are going to start with the unit 5 which is having the applications of deep learning, and as a part of that large scale deep learning we are going to discuss it in this session. So, the unit 5 is having 5 major concepts. The deep learning applications, as the part of the deep learning applications, large scale deep learning, computer vision, speech recognition, natural language processing and other applications also. All these concepts are covered in the deep learning textbook by Ian Goodfellow. So, this is the textbook cover page, and I have provided the link for the textbook also. You can directly download, and in that you have to go through the chapter 12. Now we are going to start the large scale deep learning concepts. Now already we know that deep learning, already we have done some applications also in the deep learning. So it is the subfield of machine learning, and it is having the various layers, layered architecture, and it is having the large number of layers. So the network may be very large. So, and another thing is historically from the last number of decades, the network size was increased a lot. So based on that we need some additional requirements also. And now evolution of the neural networks, they are playing the important role in so many areas, and there is the increase of the network sizes, there is the increasing of the network sizes a lot, and number of hundreds and thousands of layers are also there, and they enable to solve the complex problems. And of course we can compare that with the insect neurons in nervous system. So meaning that there are so many connections, so many communications between the neurons. So all these are involved, and the key milestones in the deep learning are there are here we have the generative AI and generation of the images and generation of the text. All these are comes under the generative AI concept, and they are using the transformers model. So the transformer is the complex architecture to execute that, to train the transformer models. We need more computation power, it is very large in size. So now we are going to discuss about, already we have the CPU, that already we know. If you execute any model, that will be executed on the CPU, that is by using our language. Our language will communicate with the operating system, the operating system will communicate with the CPU. Now here the traditional CPUs, they may be sufficient for some kind of data and some size of data, and they are not capable to work on the large amounts of data. So the traditional usage of the CPU, they are in the deep learning, especially in the deep learning, the training interface, it is very difficult, and the limitations, it is very limited. Parallelism and they have to is limited, is also there. Computations higher end, and we have to go for the floating point arithmetic for the deep learning techniques, but it is very difficult for the CPU architectures. And multi-core processing, already multi-core processing is also available, so we can perform some parallelism, we can achieve some parallelism, but it cannot be compared with other techniques, other hardware like GPUs. Now we have the GPU concept. The GPU is an additional hardware, and we can say that it is the supporting processor for the CPU. It cannot replace the CPU, but it can perform the arithmetic operations with a high speed for the large amounts of data in parallel. So the GPU, actually it was designed for the graphics, meaning that designing the graphics and displaying of the graphics, we are using this for gaming and all these other concepts. So, the benefits are parallelism. GPUs, they can handle the thousands of operations simultaneously, and it is crucial for the training the large models. So, in the models we have to perform the matrix multiplication only. In the matrix multiplication, it is the it includes the parallel processing of the various weights and the input, so that that can be performed in parallel by using the GPU, and it is having the high memory bandwidth also. It is having some high memory bandwidth and programming challenges. The problem here is, actually it is not the problem, the programmer has to familiar with the GPU architecture and also the supporting language like CUDA. So, if you want to use the GPU, we should have the CUDA programming. So, it may be having some additional burden on the programmer, and of course we have some plugins and the TensorFlow, by using the machine learning TensorFlow, PyTorch, all they are having the plugins to communicate with the CUDA, and they are having the accessibility of the GPU directly by that library. So, we can use it. And now another important thing is, of course, if the data is very large and GPU, if you want to install the GPU, it may be expensive also. So, in such cases we can go for the distributed manner. So, the alternate for the GPU, we can say that it is a small alternate for the GPU. We cannot say that completely it is the alternate, because the CPU performance, even the combination of number of CPUs performance, they may not be equal to the GPU. We have to use number of CPU cores or number of CPUs, meaning that the distributed environment. So, the distributed, large scale distributed environments, here if you have the large amount of data which cannot fit in a single machine, then we should go for the distributed environment. So, here in that, the data parallelism and model parallelism, these are the two major concepts here. If you have the very large amount of data, we have to go for the data parallelism, meaning that the data will be divided into chunks, they will be stored in different places, and then they can be retrieved and they can be executed in parallel. So, that is the data parallelism. And model parallelism, it is a process. The process can be distributed. We can initiate the process at one place and it can be distributed wherever the data is available. The process will go there and execute, and it will return the output. So, that is the model parallelism. So, data parallelism and model parallelism, these two are the major things we have to understand for the distributed implementations. And one more thing, for the model concept, not only for the processing, we have to go for the back propagation. There are several back propagation algorithms available. Generally, the back propagation is in the sequential manner, meaning that layer by layer there is the dependencies in the layers. So, if you are using the regular stochastic gradient descent, it may not fit for the parallel processing. So, we have to go for some other kind of gradient descent, stochastic gradient descent, that is called the asynchronous stochastic gradient descent. So, it allows the computation of the gradients in parallel, so that we can achieve the parallelism concept. And parameter servers are also another area, meaning that all the parameters, they will be maintained at one global area and they will be updated by the number of parallel processes, so that we can achieve the our goal to handle the large amounts of data. Now, here in this, the dynamic structure, one more concept is the dynamic structure in the neural networks. Actually, if you have the large amount of data and you have the large model which is very complex, in that how can we reduce it? If you are able to reduce something here, if you can reduce the data or you can reduce the complexity, how can you reduce the complexity? That is by taking the dynamic structure in the neural networks, that is conditional computation, meaning that we will have some condition to execute the particular neuron or to execute that particular component, meaning that it will activating the different parts of the model depending upon the input, and it will reduce the unnecessary configurations. So, unnecessary computations. Now, use of cascade and decision trees, meaning that which is useful feature, only the useful features will be retrieved, only the useful features will be captured and they will be processed. That is another kind of dynamic structure environment. So, and then we have to go for the specialized hardware. We have some other techniques also there. If we have a model, let us say for example we have the model X, related to that model X which is required, that related to that we can build a chip, we can create a chip and we can place the chip in the machine, so that whatever you are giving the model, this chip is dedicated to your model so that it can work with high speed. So, that is also another solution for large amount of data, that is called the application specific integrated circuits. And FPGAs, these are also another solution. They are the flexible hardware that can be reconfigured for different tasks and offer the balance between the performance and the adaptability, that is dynamically it will take the decisions. And low precision arithmetic, that is also the part of that, and there are several concepts involved in this. So, if you want to handle the large amounts of data and for the complex architectures, then these are the various techniques. One is the basic one is we are going with the GPUs, CPU cannot handle, so we can go for the GPUs, and we can go for the GPUs, second option. And the third option is we can go for the distributed environment, and the fourth one is the dynamic structure, and then we can go for the specialized hardware implementations. These are the various ways to handle the large data deep learning, or we can say that large scale deep learning techniques. Thank you.